with congruence. So how can you tell two shapes are identical? And the key word here, we've talked a lot about congruence in the past, but the key word here I want us to focus on is sequences. How can you describe a set of steps? So describe in detail the sequence, the series of steps of, when I say steps, I mean of rigid motions, reflections, translations, and rotations, to map one figure onto the other to check for congruence. So what do I mean by that? Here we have a couple of examples. So I want you to go ahead and draw these, and then we'll take a look at how you can say that one shape is like the other. Okay, so the first shape appears to have done the following. You first translate, let me choose a different color, choose black. You first translate along this vector. We've talked a lot about vectors in class by now. So first translate along f prime, that vector. So imagine for a moment what the shape would look like. It might be this blue shape, this crown-looking shape, but sort of where f maps onto f prime and the other points are kind of crooked. They're not mapping onto each other yet. So that's the first step, is simply to slide the blue shape over to the right along the vector f to f prime. And then what needs to happen is a rotation. So you would then rotate about point f or f prime, because they're already on top of each other, so that d maps onto d prime. So I wish I could move this particular shape, but it doesn't cooperate quite that way. But imagine for the moment that after the translation you'd have something that looks kind of like this, although I'm not a very good tablet artist. Right, the f's match, but everything else is crooked, and then rotating it so that clicks on so that all the points match up. So a series of steps there, a translation and then a rotation that shows one figure onto the other, and that shows you that these two shapes are congruent because everything matches up. Now this one's a little bit easier. If I translate h onto h prime, everything else is going to translate along the same vector, and what you should notice is that those vectors have the same magnitude. So this one actually only requires a single vector. It's a translation. So translate along the vector, whoops, let me spell along vector h prime. But what you could see is that all the vectors are congruent, so you could say any of them, frankly, and all of them would match up. So you're good in that case. So this would be just a single sequence of a single transformation. We'll have one last example, and that's this one here. This is one of my more favorite examples here, because at first you might think, well, I could just reflect, but then the question is, where do you reflect? Do you reflect along that line, maybe that line, and then how do you find the line of reflection? Well, here you want to see there's a couple things that happen. I would say the first way to start is to translate along this vector. So the intermediate step, so the green triangle would be here. Didn't draw it better than that. The green triangle would be here, L prime, M prime, K prime. And after the translation, the M's match up, so the blue triangle would kind of be like this. All right? So first, translate along M to M prime. But see, these two lines right here, let me outline them more vividly. These two lines right here don't match up yet, and they're supposed to, so this line and this line. Because if you translate along the vector, this will be kind of like this, right? So we then have to rotate about M so that L maps onto L prime. So we rotate it so that these will match up onto each other. So here's our green triangle, M prime, K prime, L prime. We just had the shape sort of in this fashion, but now after a rotation we now have it lined up like so. So the blue triangle is now here. So K prime, L prime, and M. So now we have this line of reflection. So finally we reflect across L, M. So that would be our line of reflection, and boom, K maps onto K prime. So we know that they are congruent. So translate a slide, rotate, turn it so everything lines up, and then finally a flip so that the two shapes fit exactly onto each other. So this is a longer video, but hopefully it sets the stage for some interesting investigations we'll do in class this week. All right, I'll see you in class.